All right, so let's get rolling. Let's get through the solution to the homework, and then we're going to start creating a kind of a Dungeons and Dragons-y starting point for that kind of a game. That's going to continue to have us practicing with objects, but with different data types in them, and then also lead us into inheritance and that kind of stuff. All right, so let's look at where we left off here. So homework was to write this function right here, right? Reduce the fraction by updating this fraction's numerator and denominator to be in reduced form. So we're not returning a fraction. Instead, when we ask a fraction to reduce itself, when we say something like f1 dot reduce, we expect internally that fraction to now be in reduced form. All right, that's what we're trying to accomplish here. Just for expedience purposes here, I'll go ahead and write the bad version of reducing rather than going and grabbing Euclid's algorithm. Remember, we talked about kind of the speed of this, but this will prove the point and let us move on reasonably quickly. All right, so in order to reduce a fraction, we need to get the greatest common divisor of two fractions, or of the numerator and denominator. Actually, an interesting thing here would be, let's see if the math class has greatest common divisor in it. I bet you it does. Then I'll just show you how to get, well, let's just go with Java math class. Doesn't. That's okay. All right, so we need to find the greatest common divisor. So first of all, we want to figure out what's the larger of the two or the smaller of the two values between the numerator and the denominator. So we're going to say int min is equal to, let's just make a guess and decide it's this fraction's numerator. Then we'll ask the question if this dot denominator is actually less than min. We'll update min to be this dot denominator. All right, so after these couple of lines of code, min is now equal to the smaller of numerator and denominator, which is the largest possible value that could evenly divide both of them. All right, now we'll do just a brute force type thing. So we're going to create a for loop. Print I is equal to min. I is greater than or equal to 1. I minus minus. So we'll start off at min, we'll walk down towards the number 1, which we know will evenly divide both the numerator and the denominator. Each time through, we're going to test, do you evenly divide both the numerator and the denominator? If yes, that's our greatest common divisor. Divide both, we're done. So we'll ask a question, if this dot, come on, I've typed, power through. If this dot numerator, when divided by I, is equivalent to 0, that means there's a remainder of 0 when we take the numerator and divide it by I. And this dot denominator, when divided by I, has a remainder of 0. If both of those are true, we now know that we have the largest value that evenly divides both the numerator and the denominator. So we'll say this dot numerator is equal to this dot numerator divided by I. This dot denominator is equal to this dot denominator divided by I. Now, at this point, we have reduced the fraction, correct? Do we have any more work to do? How do we exit out of a function immediately? Just return. That'll make this function end. Keep in mind, this is the often forgotten about use of return. Because really, the job of return is to end a function. It can then optionally return a value. In this case, we've advertised it doesn't actually return anything. So this means the function will just end. Go ahead.
Doesn't break do the same thing?
No. So the question here was asked, does break do the same thing? So you want to know, will that do the same thing? Now, in this particular case, it will give us the same result, but break and return do different things. What break does is this guy gets us out of the most local loop. So this would break us out of this for loop, leaving us right here. So you're right. Functionally, in this case, since we don't have any stuff after the for loop, it'll just come to its natural conclusion by hitting the closing curly brace. But break and return perform different functions. Okay. Break would be if you want to stay inside this function, but you want to get out of this for loop early. So in this case, break would actually do the same thing as if I say I is equal to 0, something like that. That means the next time through, it'll fail the Boolean expression. You know, is 0 greater than or equal to 1? Nope, we'll fall past the loop. Okay, but good question, because break's very commonly used as well. But return is, then we don't even have to look. You know, we could have 10,000 lines of code beneath us, and if we hit return, we know we're out of here. Okay, so that should be the solution for the homework. If you use the Euclidean algorithm, technically that's actually better. Most programming languages have a greatest common divisor built into it. Let's just see where it lives in Java. Java GCD function. I assumed it was in the math class, but it was not in there. Oh, it's in big integer. Oh, but to do that, we need to use the big integer class for large values, which I'm not going to show right now. That's a recursive version of it. Let's just forget about it for right now. We'll stumble upon it at some point. All right, so let's go test this. So out here in main, we'll create a couple of fractions. We'll prove that we have working fractions by asking them to display themselves. We'll then go ahead and add the fractions together, catching the result into these variables answer 1, answer 2. We will display both of those answers, which should show us the same answer, since it didn't matter if we added F1 to F2 or we added F2 to F1. Then we'll go ahead and reduce both of those fractions and then display them again, which should also give us the same values, but this should be the reduced version if the fractions can be reduced. So there's our answer 1, answer 2, 10/8. Then we reduce them, and here's our 5/4. And you can change your fractions to whatever you want. If we go and make this 121 over 200 and make this 35 over 41. They were already reduced because we picked odd numbers. Go ahead.
So right now we are only working with 2 files. So for like a typical project, how many files would you need?
Well, pretty quickly here. So I mentioned we're going to start writing a kind of our own old style game called a multi-user dungeon, a MUD. So early Dungeons and Dragons video games before we had graphical stuff. So we're going to probably end up having 5 to 7 files for that guy. You know, when you start getting into larger projects, I mean, even for a MUD, if we're going to have a very cut down version of text-based Dungeons and Dragons here. I mean, if you went full out and made, you might have 100 files. That wouldn't be uncommon. And for large applications, potentially thousands of files. That's why they get teams of developers working on them. But remember, all hard programs are made up of a bunch of easy parts. So even though there's a bunch of files, if you were to look into one of those files, it might not look any more special than this short fraction file. You know, it just is our way of kind of organizing our code into pods, encapsulation, so that we kind of know where to find the right stuff. So as an example, I'm sure it's somewhere in Java, and I really thought it was in the math library at some point, but that one thing I just saw indicated it might be built into the java.lang now, but whatever. You know, I wanted to find the built-in greatest common divisor. So I started thinking about, out of all the classes in Java, where might that guy live? Math library was a reasonable place to start. All right. Okay. So questions about this for our answer. I'm going to go ahead and switch my fractions back so you actually have a working example that shows a reduction. The other example I had, the fractions couldn't be reduced. All right, so we'll call this guy good. That up on Slack. Okay. So last time, right at the end of class, we started talking about the idea of public-private versus public-private protected. So this is the security for our objects. Typically, what we're really thinking about when we think about public-private protected is we're thinking about fields and methods. Okay. Technically, you can put this in front of constructors. Technically, you can put it in front of classes. And sometimes there's a legitimate reason to do that in terms of who you want to have access to it, but call it 98% of the time, public, private, protected, really public or private is where we'll mostly be dealing with fields. We want fields to be private if we only intend to directly access them inside of the class. If we want to directly access them outside of the class and we want to be able to read them and write them, so full access to them, might as well make them public, or if we leave nothing on there, they'll technically be package level, or in C++, that's called friend. Basically, everything in the current directory will be able to access those variables, but I would say very rarely would you legitimately want your fields inside your objects to be anything but private. The only other thing it would typically be is protected if you needed children of that guy to have access to those things. And we'll talk about inheritance here over the next couple of classes. But generally speaking, you want to control the type of access people have to your fields. So whether if you want to give them read-only access, which I think we did an example of that last time. At some point I did. So we were messing around with our fields here. And if I made numerator, for example, private, you know, if I make them both private right now, which is my rule of thumb, I said make everything private and loosen the reins as needed. All right. If I do this, code should currently work the same way as it's working now. Why is that? Well, out in driver, I'm not trying to access these things. But if I were to do something like int LOL is equal to f1.numerator, something like that, and I wanted to gain, so I'm trying right here, I'm trying to directly access a field from fraction. Now we have made the numerator field private. So because we made it private, Java's not going to be happy with this because we are trying to access a private field in a file other than fraction. Private means that numerator and denominator are only accessible inside of this class. Make sense? So if I run this right now, Java is going to scream at us. Numerator has private access in fraction. So what we mentioned at the end of class last time is, you know, what if we want our variables to not be externally changeable, right? Not be externally changeable, but internally, but maybe we want them to be read-only externally. We want people to be able to get the value of it, but not modify the value of it. That's when we get into the idea of these things called getters and setters. Okay, so and these have had other names over the years. The current cool name for these would be getters and setters. So a getter is a method that gives public access. Let's call it public read-only access to a private field. Setter is a method that gives public access to change a private, so to write to a private field. All right. Now, historically, anybody know what some of these things went by in yesteryear? So these guys used to be called accessor methods. Getters were accessors. And setters were called mutators. They change it, mutate it. All right, so if you ever see something like that, these are all just names. This has nothing to do in Java with any sort of special syntax. Some newer languages, like for instance, C# has built-in access to create security access to your various properties, your fields. So there's actually a special syntax where you don't even have to write specifically the getter and setter. You can just, when you define that field, you can mark it as whether or not it should have a getter, a setter, or both. I would say it's pretty rare to have generic setters. A setter means that you have the ability to just randomly change the variable. I'll just show you a couple of these here with our fractions. So we saw we have an error right now with our F1 numerator. So if we wanted to give driver read-only access to that guy, what I would do is we actually already wrote it last class. I might write a function called get numerator. It does not need to be named like this. Just typically, you would name your getters something like get followed by whatever the name of the field was. Naming convention. But you can name your function elephant if you wanted to. They don't care. Probably make it meaningful. So instead of us directly accessing a private field like this, and I'll go ahead. I mean, right now it is package level security. So I do have access to get numerator external to this, but it's probably most correct to make it public, where we're basically saying we publicly are making the numerator's value available. You can't change it, but you can get the value. No harm to that. So then out here in driver, this is still an error. Okay, we don't just magically get access to it. All right. But now we can call get numerator here, and that will then get us that value of numerator. Right now, we're just storing it inside of LOL. We're not using it, but notice it's not an error anymore because now we have read-only access to our private field numerator through this public method called get numerator. And all this guy does is returns the numerator. This guy lives inside of the class called fraction, which does have access to the numerator. Okay, so that's an example of a getter. Now, a setter, public void set numerator, would look something like this, where we can now externally modify our numerator by calling f1.set numerator, passing it a -2 or something like that. That would then go into this function as the new value, and we are just directly setting the new value equal to this. Now, in this particular case, if we happen to write both of these exactly like we have them written right now, with effectively no oversight, we might as well have just made the field public, right? But let's assume that maybe for set numerator, we only want to let them set it to a positive value or something like that. Or maybe for denominator, they can't set it to 0, that kind of stuff. So now we could wrap it. We could say if new value is greater than 0, then we'll go ahead and change it. So this could be an example of when we do want to use getters and setters. I mean, for fractions, we're kind of pushing the envelope a little bit here. I feel like, fractions are getting a little boring. That's why we're going to move to a game now. But if we did want to give them access to change the numerator, we might want to conditionally let them do it by adding some rules, right? So having a setter giving us the ability to throw if statements or whatever other logic we want in there is better than just making the variable public where they can change it to whatever they want. Make some sense? So this gives us control over how we might want these things to change. A very, very, very high percentage of the time, your fields will always be private. I think I maybe mentioned last class, if when you get to the point where you're just writing code to solve a quick, stupid problem and your code's going to exist for 20 minutes just for your uses, and then it's going to disappear off the face of the earth. Maybe you decide, I'm just going to make these things public so I can use them quickly instead of writing a couple of getters and setters when I'm the only one using it. We'll call that allowed as soon as you understand that that's a thing and you fully understand the deal. But until that happens, make everything private and let Java scream at you until you figure it out. Make some sense? And I'm still seeing on homework assignments, for example, people not using the curly brace with if statements and stuff like that. Like I said, this isn't wrong. I'm not taking off points or anything for this, but I would consider this always a bad idea. I've been programming longer than I think all of you have been alive. I still put curly braces around everything. And I promise you, I understand how it works. It's just bad programming practice. You're going to run into problems, and those are going to be very, very, very difficult errors to track down. And that happens so often for people who came from a Python background. It's one of the reasons why I don't use Python in here as your first language. I don't have anything against Python. Great language, quick language. It's actually probably the outside of our, compiled languages, probably Java and C# are in industry more used in computer science industry than Python. But in data science and machine learning, Python's the go-to language. So don't discount it. I'm not knocking Python. It's just a bad first programming language because it lets you get away with so much. You don't have that. You don't get that structure. All right. I actually like Python's indentation thing where Python forces you. So if I was writing this if statement in Python, curly braces don't exist in Python as part of their syntax. Instead, what they say is, oh, just indent the stuff you want to belong to this if statement underneath the if statement, and now it belongs to it. So I like Python from a perspective that it forces the programmer to format their code, to indent stuff. But if you're coming from a Python background and you're expecting that to work like this, it doesn't. And these are going to be difficult bugs to hunt down because it's easy to just look past this. This isn't like a misspelled variable name or something like that. This at a glance is fine. So I would really, really, really encourage folks to emphasize always using those curly braces. Similarly, I know a lot of folks they write their if statements like that. It's fine, not the end of the world. Plenty of people in industry write it this way. This is way more acceptable than no curly braces, but I'd still encourage you to write it like this. That allows you to see from bottom to top where your if statement in this case begins and ends. I just think it's a better a better way of looking at it. All right, so there's our getter and setter quick example. We're going to see these in practice plenty of times. So let's just move on to our kind of the start of our game and see where things take us. Sound good?
I'm sorry, why did you write that twice?
Oh, I mean, you could have changed this to whatever you want. I was just showing you have more than one value in here. You know, I could have also said this dot denominator is equal to this dot numerator, I don't know, divided by 2 or something. I'm just putting random lines of code in there to show that what if I want to do more than one thing is associated with this if statement. It has nothing
Okay.
logic of this problem.
Okay.
All right, so let me go ahead and let's create a new project. And make sure it's Java. And let's go ahead and save this as CSC2000 fall 2024. We'll call this guy Deathmatch. All right. And like I did previously, I'm going to go ahead and rename my main file to be called driver. You don't like doing that, that's fine. But make sure if you rename your file driver, you also rename the class. Doesn't really help when your template puts the curly brace in the place I don't like. So it is very common. All right, so we have our working hello world program. All right. So if we're starting to think about a video game, typically with a game, and we're going to stay very text-based here. Next semester, we'll start working with a game engine, Unity, where we make things look pretty, and we'll actually take our baseline here, port it to C#, and then put a graphical front end on it where we have, you know, actual monsters running around. So it'll be super 4K resolution, very high quality. It won't be. So keep your expectations low. If you're a graphic artist, you'll have all the flexibility you want to make way prettier things than I will. I promise. All right, so let's go to our slides here and let's start designing this guy. So for starters, our game is going to have players, right? We're not going to think about the entire game yet. We're just going to get a starting point. So we have this idea of a player. Now, I know not all of you have played, not all of you are gamers, or maybe you have never played Dungeons and Dragons or something like that. But for those of you who have, if we want to think about a very simplified version of what a player is in the game, maybe players have names. Okay. Typically in these kind of games, the player's amount of life before they die is maybe called hit points, HP. So hit points, something like that. And they typically have at least one other stat. So we're going to start off here with our, because we're going to have our players fight each other to the death. We're going to create multiple instances of players, and then we're just going to have them beat up on each other. All right, until somebody dies, and we'll, whatever. That is kind of our starting point here. So a lot of times what you might do is you might have one stat like strength that dictates how hard you can swing or something like that. All right. So we'll say strength. Oh, yeah. No, I won't put types in here. And then maybe lastly, from a Dungeons and Dragons perspective, a lot of times the player might have an armor class, like typically in Dungeons and Dragons, like I think it all uses D20 gaming system now. You roll a 20-sided dice. You decide, do I hit the guy I'm trying to swing at? You only hit him if you roll on your 20-sided dice at least what their armor class is. And then if you clear their armor class, then you roll damage. How hard do I hit him? And then you actually hit him, and then his hit points go down. All right. If you don't clear his armor class, then effectively you take a swing and you missed. No damage done. If you really miss it, Dungeons and Dragons, a lot of times if you like your D20, you roll a 1, you might hurt yourself. You might stab yourself in the leg or something like that. So let's write an armor class thing in here. So now, instead of our fraction object that we were dealing with before that had 2 fields, both of them integers, Now our player, at least the first version of it, later on it's going to have more stuff than this, but our first version of it now has 4 fields. It's going to have a name. What kind of value is name probably going to be? String, okay. Hit points, probably an integer. Strength, probably an integer. Armor class, probably an integer. All right, so we're going to have a string and 3 ints here. So just from our design so far, let's go ahead and create the framework for this guy. And this is something that I might ask you to do on like an exam where I give you something along the lines of this. I say, create a class for something. Here are the attributes of this type of thing. Give me an object that has the correct kind of constructor, the fields, and initializes everything, something like that. Go ahead.
Thinking about the exam, is it gonna be cumulative or is it only just gonna be regarding the second semester?
I mean, really, the answer is yes, because I mean, he asked for all 9 people, he asked, is the exam going to be cumulative? I mean, yes, it is, but the emphasis will be on things since the midterm. But keep in mind, you're still going to have to be able to define variables, write if statements, loops. So all those things before the midterm were kind of fundamental things that are going to exist in your programs that you write 15 years from now in industry. Okay, so it is cumulative, but the focus will be on the stuff we've done. I probably wouldn't ask you to write a Hello World program, for example. And also just, I'll just throw it out there now. I will probably make the final exam a little bit shorter than the midterm, but with still plenty of time to do it. I think kind of universally it took people longer than I anticipated it taking folks. So I think it should feel like less of a time crunch on the final. So I'll take that into consideration. Maybe I'll throw a couple of less coding questions in there, or maybe something where I show you some code and you tell me what it does, whatever. But know that I've understood that that was a challenge for some people. It was most obvious when I had somebody who like aced the exam for 7 out of 10 questions that didn't get to the last 3. That's not my intent for that person to end up with a 70 on that exam. They'll end up coming back and doing well on the final, but that's not what I was going for. And I think that was what some people ran into. All right, so let's go write our player. So we're going to go ahead, we're going to create a new file. Call this guy player.java. You don't actually have to say public class. We'll just leave it as class player. Wouldn't make any difference for what we're doing right here, but it's not muddy the waters. If I say public class and it's accessible by everyone, not just who's sitting in this current directory, doesn't matter for us. All right, so now we want to have 4 fields: a name, hit point, strength, and armor class. So we'll have a string name, int HP, int str for strength, and int AC for armor class. And we could even put little comments here. This is hit points. And armor class. All right. And as we've discussed, we're going to go ahead and make everything private initially. And then we'll loosen the reins if we need to. All right. So those are the 4 pieces of information. Oh, forgot to put private on this guy. So those are our 4 fields we're going to be keeping track of for our player. Now we want to have our constructor, because when we first bring a player into existence, we're going to go ahead and need to initialize them. All right, so the constructor has to match the name of the class, and there's no return type. So the constructor is going to be a method-looking thing called player. All right, now to build a player, we might initially look at something like this and say, well, I need to have 4 different things being passed in. I need them to give me the name, the hit points, the strength, and the armor class. Okay. Now, realistically, if you think about it, when you play Dungeons and Dragons and you have your character sheet sitting in front of you, you write your name at the top of it. That's your given information. All you needed to start your player was the name. Then you started rolling dice to generate those other values. Okay. So really, to create a player, all we're going to need is a name. And then inside the constructor, we will set those other values randomly. In this particular case, because of the problem we're solving here. If we were solving a different problem where we did need to take in all 4 of those values, we would certainly write them. So we're going to take in a string name. And we'll say this dot name is equal to name. That is to say, we're going to set this version of name equal to the name that was passed in. All right. Now randomly set the other fields. All right. So I mentioned that we might want to roll some dice. All right. So in Dungeons and Dragons, typically we have 20-sided a D20 for most of our rolls. So let's go ahead and create another class for dice. Because as our game goes on, we might want to, we might have to use a D20. We might have to use 3 D6s. We might have to use a D12, whatever it is. So we want to have this ability to create instances of dice that have this number of sides in them that are of interest to us. Okay. So we'll pause our player for a second here. And we'll stick with our thing to design. So we'll go ahead and say we're going to have another class called dice. Dice will have a number of sides. Okay. And then we also want dice to be able to roll. So maybe we say something like fields, sides, methods, at least roll. All right. So we'll create our new class. This guy will be called dice.java. This will be class dice. All right. We're going to have our private int sides for the number of sides for this dice, this die. Okay, we're going to have our constructor public dice. I didn't make player public, but we probably would. Typically, constructors are public, but it still would have worked. And dice is going to take in a number of sides. Let's call this sides, not side. We'll say this dot sides is equal to sides. All right, then we're going to have a function called roll that returns an int that rolls this particular dice, this particular die. If it has 20 sides, it's going to give me a value between 1 and 20. If it has 6 sides, it's going to give me a value between 1 and 6, so on and so forth. All right, so the roll function, the roll method, will return an int. It's called roll. It takes no parameters. Because when I tell that dice to roll itself, it already knows how many sides it has. It has this dot sides number of sides. All right. So now we need to figure out, how do I do random numbers? So we have a class in Java. It lives in java.util, random class Java. Well, I want to go to the actual Java documentation. All right, so here's our random class. We have 2 different constructors. Notice they have the same name, but a different number and or type of parameters. What's that called? Polymorphism. All right, Realistically, if we're dealing with random number generators, the difference here is if I just say random, the no argument constructor, it will create a new random number generator. And nowadays it does seed the value for you using some sort of default seeding thing. When we talk about random number generators, to seed the value, a lot of times we're seeding it off of like the milliseconds on the clock or something. That way, every single time you run your program, you're not getting the same sequence of values. All right. Java used to work, this class in the early days of Java, the no argument constructor here did not use a seed value. So every single time you ran your program, you got the same sequence of random numbers. Now, in some cases, that's actually kind of good, because if you're debugging your program and you want to have a lot of different values, but you want to be able to kind of work the kinks out over multiple runs of the program, having the same sequence of random numbers can help you find some bugs and stuff like that. As opposed to every single time you run it, you get unique strings of random numbers. But in practice, typically when you are working with a random number generator, you expect it to give you random values. And if you run your program 10 times, you're going to get 10 different sequences of random numbers. So now, even if we use the normal constructor, we will get that. We'll get the different sequences of random numbers. The only reason you'd use the second one is if you wanted to create your own seed value. Maybe you had a preference for a seed value. There's a whole science in computer science and cryptography around random number generators. Like what are true sources of randomness, this kind of stuff. It's actually difficult to get true sources of randomness. All right, so we'll go ahead and use our normal random number generator here. Oh, that's right, we're web-based. All right, so what I'm going to do here is inside of roll, I could always say random R is equal to new random. So now I'm using a built-in class here. And then I can return R dot, I think it's called next int. Let's go look at the values here. So these are the constructors. Here's the methods. Notice the random number generator will allow us to generate random values with all sorts of different things. I can generate a random true or false. I can generate a value of a certain number of bits. I can get a double value, a float value. This would be used for like AI stuff and other fit algorithms. Next int is the common one, probably our most common one, because we're just generating integers here. Okay. Now, next int returns a pseudo-random number uniformly distributed between 0 and the specified value exclusive. So the possible values will be 0 up to, but not including whatever value you told it to give you, if you use this version of nextint. So if I use nextint, I pass it a number like 10, it'll give me a value between 0 and 9. Or I can use the normal version of nextint, which returns a value uniformly distributed across all of the range of values that can live in an int. So what would be that range roughly? If I generate a random integer in the range of all integers, what's the smallest value I could get? What's the largest value I can get roughly? This goes back to when we first talked about primitive types and learned how big an int is compared to how big a long is, compared to how big a short is, that kind of stuff. How many bits is an integer in most modern languages? 32. Okay, so what are the range of values that can fit inside of 32 bits? 2 to the 32. 2 to the 32 if it was unsigned. If it was signed, which ints can hold negative numbers and positive numbers, it would hold roughly plus or minus 2 to the 31st power. And that's roughly 2.1 billion is what 2 to the 31st power is. 2 to the 31st power is 2.147 billion. All right. So that means if I call nextint with no inputs, no parameters, it would give me some number between negative 2.1 billion and positive 2.1 billion. Maybe that's what you want. You got 4.2 billion different values it can be. Okay, in our case, we want to roll a value between 1 and the number of sides, inclusive. Okay, makes some sense? So let's start off by just returning the random number in the range of all random number, range of all integers, just so we can see this. Okay. We'll go back out to driver. We're going to not use our player for a minute. We've designed it. We have this blueprint living there, but we haven't actually used it. We're not going to use it quite yet. So I'll go back to driver. I'm going to go ahead and create myself an instance of dice. So I'll say dice D is equal to a new dice. Put 20 in there. Here, I'll actually call this D20. All right. And we see that the dice class has a roll method that takes no parameters and returns for me an int. So let's just go call my roll method 10 times. So I want to do something 10 times. So for int I is equal to 0, I is less than 10, I plus plus. And we'll just go ahead and output d20.roll. All right. So we're not storing it anywhere, but we're going to go through 10 times. We'll print out the results of calling the roll method that is owned by D20. So this should give me 10 values between negative 2.1 billion and positive 2.1 billion. Go ahead and run this. Oop. My apologies. In Java, strings are capital S. C# is lowercase s. Obviously, completely different languages. All right. Oh, same problem. My constructor. Okay, I mentioned that the random class lives inside of a library called java.util. So right now, inside of Dice, I'm trying to use this class that I didn't write. This is something that's in the Java programming language. All right, so I need to make sure I have access to that guy. If I go and show the documentation here, we scroll to the top, we see that this guy lives inside of a library called java.util. So what we would do is at the top of our code, we could say we want to import java.util. Now, a common thing to do would just say import java.util.star. That says, give me everything that lives inside of java.util. So if I go back out here, is that clickable? Not clickable. So if I go up here to packages and I go and find java.util, here's all of the classes that live inside of java.util. Lots of stuff. We're using one of them right now. We're using random. So if I say import java.util.star, it'll work just fine. I get random plus all that other stuff. That will make your executable larger, even though we're only using, because we're only using one of these pieces, we're still getting the whole thing included in our code. Is that the end of the world for us? Probably not. In fact, most modern IDEs for Java, if I start using the random class, it'll automatically import just java.util.random. It would put something like this at the top of your code. Just say, just give me access to that random class that I want to use here. And then if we used another class from util, we would import that java.util. Whatever the other class is. All right, so now inside of Dice, we've imported the random class, so we have access to it. Inside of roll, I'm creating an instance of this guy. We're actually going to move that here in a few minutes, but he's fine where he's at for the moment. All right, so now we have our 10 values in the range of all integers. If I run this again, you'll see we get different values. I just remember the first one started with a 180, so different value. All right. So we see that it's seeding itself probably good enough for us. All right. But now we know that this guy is giving, or I'm sorry, this guy is giving us a value in the range of all integers. What if I put 100 in there? Now, keep in mind, you can't just always do this with any kind of class. You can't just randomly pick and choose like, oh, well, I want to put some extra crap inside those parentheses. It has to have a version of this method that expects that. Okay. And if you remember, we went back and we looked at the random class and we saw that there's actually two versions of nextInt. There's one that takes no inputs and there's one that takes a single integer. The single integer one will give us a value between 0 and whatever value we put in there minus 1. Which means this should give me a value between 0 and 99. So now if I run my program again, we'll see we have 10 values between 0 and 99. Okay. So back here in dice, for every instance of dice, I'd like to have it return when every time I roll it, I want it to give me a value between 1 and the number of sides. Knowing only what we know now, how can I make sure that this guy returns a value between 1 and however many sides this has? How many sides is in this dice right now? Well, we named it D20, but how many sides does this particular dice have? Generically.
100.
I just wrote 100 in here. That's just a hard-coded number. How many sides does this particular dice? I'm in an instance method, roll, that lives inside the dice class. I'm asking you, how many sides does this dice have generically? Basically, it's the same question I used to ask you about strings when I said, how many characters are in this string? It's this dot sides, number of sides, right? The example we've written right now, we did create a single dice. We named it D20, and we happened to say this guy has 20 sides, but nothing's preventing me from bringing into existence a second dice. Maybe we call this guy a D10, and he has 10 sides. So when we're inside of the blueprint for our class dice, when I'm writing this code in here, I have to write it generically. So when I'm sitting in here and I ask myself, how many sides does this instance of dice have? The number of sides is this dot sides. This dot sides for D20 will be 20. This dot sides for D10 will be 10. And just so you're not connecting it to the variable names, the number of sides for my dice named Woot will be, I don't know, 200. So this dot sides inside of Woot would be 200. That makes some sense? So then the question is, if I'm in this roll method here, and I want this guy to return an integer between 1 and the number of sides, how would I manipulate this code to give me a value between 1 and the number of sides? Good.
So it's giving 0. It's giving a number from 0 to sides minus 1 right now.
Mhm.
So it's going to be plus 1.
Yep. So we can say this dot sides. So this will give us a random number right here. This will give us a random number between 0 and this dot sides minus 1. So if this dot sides is 20, I'd get a number between 0 and 19. If I then just take the result of that and add 1 to it, now I have a value between 1 and 20. or in this generically 1 and this dot sides. So go ahead and run this. There's a bunch of numbers between 1 and 20. I'll go back out here to driver. If instead of telling my D20 to roll, if I instead say, hey, I want to roll the D10 a bunch of times, I've changed no other code other than I just picked up a different dice. Remember, this is object-oriented programming. The D&D players, when they come there, they got their bag of dice, they dump it out. Okay, you always bring lots of extra D6s in case you're playing a wizard. And you get to a level 20 wizard, you start dropping just fireballs. No D&D players in here. Oh, killing me. I remember as like a 10-year-old, I'd sit in like my buddy's basement. I just pick up like a whole there's not enough here, but your guy's about to die. Just throw him down. A lot of times it was actually D4s. You don't want to step on one of those. They should use that in war. All right. So in any case, if I roll my D10 now, it's like I just picked up a 10-sided dice off the floor, off the table, whatever. And now I'm going to roll that guy. I expect him to give me a value between 1 and 10. If I pick up a D20, I expect him to give me a value between 1 and 20, so on and so forth. Okay, so we're starting to see how we use objects related to real life things now. Okay, so I have 3 different dice here. This is probably something I bought on sale at one of those conventions, the Woot dice. I used to have, in a former life, I would go to, there used to be this conference called Origins. I don't think they have it anymore, but it was a big, like, tabletop gaming type thing. And you had a whole bunch of people who invented different board games and stuff. Well, I was one of the volunteer dungeon masters for it. So we'd have our dice around our neck. I had dice made of asteroid. People there thought that was cool. My mom, not so much. Was not impressed with my $600 dice made of asteroids. And they were super tiny. Little tiny dice, but they weighed like, I don't know, 4 or 5 ounces for a D20. It was ridiculous and completely impractical. I still have them somewhere. All right, so now we're going to roll our D10 10 times. We expect to only see values between 1 and 10. So there's my values between 1 and 10. If I pick up my Woot dice, roll that, I should see values between 1 and 200. So now just by creating this simple little class, I mean, this class does, it has what, 17 lines in it? And that's with me using, my more verbose curly brace formatting, right? Where I kick it down to the next line and things like that. I have some extra spaces in here for readability. So at most, this is 17 lines of code. I now can generate an infinite number of different sided dice. Well, I guess technically not infinite. I will run out of integer space. Well, I could create an infinite number of them until I run out of memory, but I can only create dice up to 2.1 billion sides before we start running into issues. All right, so now I have the ability to just generate dice at will. Now, one thing I would probably say here, it's not the end of the world, but in this case right now, every single time I call roll, I'm generating a brand new instance of random. That gets seeded, so I'll still have random numbers and stuff. Okay, but if you're kind of thinking about this from an efficiency perspective, what we might want to do is when that D20 is first born, when I'm creating my instance of D20 right here, he comes with an initial random number generator that we then just call every single time we call roll. We don't reinvent the random number generator every single time, because then we're destroying memory, recreating memory. It's kind of wasteful, kind of inefficient, but you probably wouldn't notice on your end. But if we want to follow some good programming practice, we would probably say something like this. Okay, well, I know I need a random number generator for this class. What I'm going to do is I'm going to create my random number generator up here globally. It'll be a field. I'm going to make it private. So down here, I could still say r.nextInt because remember variables resolve to their most local definition. And is there a variable in here named r? Nope. So the next place it's going to look is up here and it finds r right there.
Sorry, why did we have to return this dot sides?
We're not returning this dot sides. We're using
And why
this
is that?
sides in the context of this larger line. So this dot sides is an integer that's getting passed in to the next int method of the random class. And if we go and look at the documentation here, here's next int that takes an integer. So we're passing this dot sides in for this guy right here, which will then give us a value between
Can't
0.
we just return the value of that instead of this dot sides?
Well, then I'm going to get a number between, I am. Are you saying why can I return the result of
I guess not.
this guy? Yeah, look at my code. I'm returning the result of all of that. This part right here will give me a value between 0 and sides minus 1. Then I'm adding 1 to that, and I'm returning whatever that value ends up being. That's the value I'm returning. The result
Okay.
of that whole thing. This dot sides is just the value I'm passing in to the next int method, which is owned by the random class. All right, so I'll generate my random number generator one time up here. You could even make the argument that we'll go ahead and generate it in the constructor. So all you have up here is fields. So I could say something like this dot r is equal to new random, like that. Constructors only get called one time. So when I first build an instance of dice, he will set the sides to whatever the sides that were passed in, and then he'll go ahead and initialize his random number generator. All right. And maybe we call this guy RNG instead of just R, random number generator. So now it's this dot RNG for random number generator. So down here, whenever I want to roll, I'll say this dot RNG dot nextInt. Even though we saw we don't technically need the this in front of there because there is no variable defined here named RNG. So it would find that guy. But good programming practice would be use the this keyword to explicitly say where this guy was found. So whenever I roll, I'm going to call this instance of randoms, random number generator. I'm going to call that dude's next int method that takes an integer as a parameter. The integer I'm going to pass it is my number of sides for this particular dice, however many sides that is. That's going to give me some number between 0 and sides minus 1. And then I'll just add 1 to that to give me a value between 1 and sides. So doing it this way, we're going to get the same exact results out to the screen. Just under the hood, we've built it slightly differently. A little bit more memory efficient here. Nobody's losing sleep if you do it the first way. All right, it's not a huge deal.
And how does this dot sides store the number of sides?
How does dice store the number of sides? Right here, the constructor. A constructor's job is to initialize values. So when we build a dice object, it's expecting us to pass in a number of sides, which we did out here. When I built this dice and I called its constructor, this was sides for that guy. This was sides for that guy. This was sides for that guy.
Oh, so you're just telling what to send the function. Got it.
Well, not to send the function. I mean, to build right here, I'm building 3 different dice. And each of those dice has a different number of sides as I have it written here. I could put 20 dice that all have 20 sides if I wanted to. But each of those dice is an instance of the dice class, which means each of those has their own version of this variable called sides. So go ahead.
That in sides is basically asking for the number of sides, and we provide it in driver.
Yeah, in this case, we provided it in driver. Nothing prevents me from creating instances of dice inside of player. In fact, we are going to put it there pretty soon. But to expand it a little bit, dice exists here. I can use this class anywhere inside the same directory. In this particular case, I'm doing examples of it inside a driver, as you said. I'm creating 3 different dice. One has 20 sides, one has 10 sides, one has 200 sides. Inside of each of those dice, they have a constructor. This constructor is being called right here. Remember, constructors do not have a return type because they're always following the new keyword, because they always boil down to a memory address, and Java takes care of all that for us. Okay, but this is a call to the constructor. My constructor expects me to pass it an int. This is another call to the constructor. This is another call to the constructor. 3 different constructors for 3 different instances of dice. Each one takes whatever number you pass in here and sets that guy's field for sides equal to that value. That field right here then gets used inside of my roll method to make sure it's generating a random number in the right range. Make some sense? How this is all kind of coming together? All right.
Yeah.
So now we have our guy generating random values. This is, I don't know if I ran this one yet, but I'm going to generate 10 values between 1 and 200 because I'm rolling my Woot dice. So there's my 10 values between 1 and 100. So with just 17 lines of code, I now have the ability to just infinitely create dice with any number of sides I want. That's supposed to be cool. All right, so we're going to use dice like that for our game here. All right. So now what we might do is we might say, well, what should hit points and strength and armor class be? So maybe hit points, maybe a value between, call it 15 and 30, maybe. We might just decide the generic player ends up with a random number of hit points between 15 and 30. And those hit points will get set inside this constructor as we are initializing hit points. Maybe strength is a value between 8 and 12. I mean, at this point, I'm just making up numbers. All right. And maybe armor class, since typically you're rolling a D20 to see if you clear their armor class, it would probably be some value between maybe 5 and 17, something like that. A value between 5 and 17. So we'll say set the rest of the fields to the values described in the comment next to them. All right. So this will be part of your homework. So let me go ahead and save this. All right. So now what I want to do is I want to keep moving along a little bit to kind of talk about kind of where we're going next, because we're going to be starting to talk about static versus non-static class members. And these would come in the form of fields. So this is related to fields and methods, not constructors. There would never be a constructor that's static. It doesn't make sense. It'll make sense why it doesn't make sense once we get into it. All right, so it's a self-policing thing. If you find yourself trying to write a static constructor, you got to really ask yourself what you're trying to accomplish here. All right, So let me show you in documentation here what we're talking about. So I'm going to open up a second file. Let's do character class Java. This guy has a bunch of static methods in it. All right. So here's my method summary for this class called character that lives in Java. It is a Java has classes for all the primitive types. We have a class called character. We have a class called integer. We have a class called double, Boolean, so on and so forth. Okay. Why do you think? So the character class, as you might guess, probably does things to chars. Why does that guy need to exist? Don't we already have chars? What's the problem with a char? What is the definition of a primitive type? They're built into the language and they can only hold a value. Primitive types don't do any extra magic stuff. They hold a value. Now, is it reasonable that we might want to ask a question like, hey, is a certain character uppercase? Or is a certain character lowercase? Is it a digit? Can I make it to uppercase? Let's convert this character to uppercase. You know, we've done the whole ASCII or Unicode math thingy, right, to make this work. But it kind of makes sense that if somebody gave me, you know, like a little blender thing that I can drop chars into, and it has a couple of buttons, 2 uppercase, 2 lowercase, whatever, and it pops out an updated char, that could be a handy little tool. Probably sold on the Home Shopping Network, or does that even exist anymore? Or is everything just on the internet? So it makes sense. Java has classes for all these because our primitive types can't do these things to themselves. They need this helper class to do it. All right. We're only going to be able to start the conversation related to this for time, but notice here that in the character class, many of these methods have this word static in front of it. All right. We observe that, right? When we look at the random class here and we look at the methods, notice that most of these, in fact, in this case, all of these, do not have static in front of them. All right, we've observed that fact as well. All right, so then your question is, you've heard me say before that one of the most powerful tools you have as a programmer is your ability to read documentation, because you're not going to memorize the entire language. Like I've said before, I started coding in Java the day it came out. I probably only use 10 or 20% of the language. I mean, if you look at Java, there's thousands of objects. Many of them are for very specific tasks that I've never bumped into needing to use them. Okay, so we're very reliant on being able to go and look at the documentation, have it instantly tell us, A, what tool do I need? And B, how do I call this? And one of the main reasons one of the main reasons to learn static versus non-static is it gives us instant information about how we call this guy. All right. So I'm going to create a slide here called defining methods fields. When defining a static method or field, we include the word static prior to the method or field definition. We haven't talked about why we might do that yet, but just if we've somehow come to the conclusion that we want to create a static field or a static method, the only thing we have to do is put the word static there. When defining a non-static, a lot of times I'll call these guys instance method / field, we do not include the word static prior to the method or field definition. Okay, so when we write it ourselves, the only thing that we change is whether or not we put static there or don't put static there. And I'll just start the next slide and remind myself to pick up there. Okay, so using static versus non-static methods fields. Start here. All right, so I will put the homework assignment up for over the weekend, just so I verbally say it, for you to go back if you're running into problems. I've put next to comments here the values that I'd like your hit points, your strength, and your armor class to be, the range of values. So what I want you to do is update this constructor such that it uses instances of dice to set those values randomly. All right. Then write a, actually, I'm not gonna predefine it for you. Then I want you to write a display method for player so that you can generate a couple of players, ask them to display themselves, and presumably we should see a different collection of stats for those players because they were randomly generated. All right. Questions, comments, concerns, bribes? All right. I'll see everybody on Tuesday. Yeah, I mean, this is probably 3, 6, 7 lines of code. But that doesn't mean it'll be trivial because we're connecting the dots. If you've never used objects before, you know. So, yep, you take care. 1 second. Let me make sure there were no online questions. Okay. Stop share.